Ladies and gentlemen, wow, that is some powerful amplification. Kai, would you please join me? And is Shrek here? Any of the other working group members? Yes, Austin, great. Anybody else from the WebGL working group, regular attendee? Yes? No? That's it? All right. Somewhat sparse representation, but believe me, there are multiple browsers that implement this specification. So please, come over, join me for the presentation. Okay, so, oops. Let me get that full screen for you. Okay. Can you see us? Can you hear us? Good? Okay, so ladies and gentlemen, welcome to the event that you've all been waiting for. The WebGL Birds of a Feather session, SIGGRAPH 2019. Thank you for coming. It's great to see you all. All right, so we are representing the WebGL working group. Brief introductions. My name is Ken Russell. I work on Chrome at Google, and I'm the chair of the WebGL working group.
Hi, Kai Ninomiya. I work on Chrome on WebGL.
Hi, Austin Eng. I work on Chrome on WebGL.
So please come over this side. Stick with me for this. Okay, so before you whip out your cameras, all of these slides are already online. So just search for Khronos WebGL presentations. You've got them there. We're not going to have time to go through all of this stuff. So please take your time, peruse it offline, try all the demos. They're awesome. We're not going to have time to even go through hardly any of them. So we'll give you a brief update of what's sort of new in the WebGL ecosystem. We have a long speaker list. So you're going to see updates from multiple domains, multiple industries. It's really cool. Lots of new cool WebGL projects came out this year. Have you all heard about Basis Universal? Okay, if you haven't heard of Basis Universal, this is the most significant improvement to the WebGL ecosystem ever, I think. It's a universal compressed texture format, and it has the download size of a JPEG. So for the cost of a JPEG, you can get a 4x improvement in your GPU memory consumption for your textures. This is amazing. This is a collaboration with Binomial, based in Seattle. They're awesome. And it's already integrated in Three.js and a bunch of other engines, so please go check this out. This is incredible. You probably saw that Minecraft Classic came out in the browser. Finally, it could have been done a while ago, but it's better late than never. Google Earth is out in all browsers via WebAssembly. That's awesome. I'm really psyched about that. Doom 3 is out via WebAssembly, so only 10 years behind the curve, but some cool top content is coming to the browsers. Medical researchers are using WebGL to do heart arrhythmia simulations. I mean, it's really cool to see all the industries that this technology is showing up in. I'd like to show you one quick demo of a building information modeling system. It's called ZeoKit. I should have preloaded this. But this is the best way to share information among all the parties that are doing construction projects, because you don't need any client software, just a web browser, and that exists on every device that you've got. This is the way to improve communication in all industries. So, please go check out these demos offline, all right? There's just not enough time to do justice to all of them. So, just a brief update on what we've been focusing on. We're working on conformance, I think it's safe to say, trying to get all the implementations to pass the top-of-tree tests. We're resolving lots of corner cases. We're getting bug reports from you, the community, and turning those into conformance tests where possible. So where you see bugs or behavioral differences, we want to resolve these to improve your application portability. So please keep these coming. We are also collaborating with Apple to integrate the Engel project into Safari's WebGL backend. And that's a lot of buzzwords. So if you didn't understand it all, just come talk to me later. And this is for better compatibility and feature support. And there's a public WebKit bug that you can track for more updates on that. WebGL 2 Compute is the single largest WebGL-specific advancement in recent times. You're going to hear more about it from Yang later, but this basically gives you compute shaders on the web today, on some platforms. It's available in current Chromium behind command line flags in Windows and Linux. There are some demos out there that will get you started. The TensorFlow JS folks are picking it up, and they're doing a backend for it. And if you invest the time to do some compute shaders with this specification, they will be forward compatible with future specifications that are doing compute shaders on the web a bit more portably. So it wouldn't be time wasted, it would be time well spent to start picking this up and see what you can do with it. We're working on addressing the biggest customer complaints. Requests. So slow shader compilation on some platforms, namely Windows, has been a problem since WebGL's inception, and this has finally categorically been solved by Intel. Thank you, Intel's web graphics team. This one extension with a few lines of application code change lets you move your shader compiles to a different thread and parallelize them, so things speed up and become async. It's great. It's already in Chrome on Windows, which is, Windows is the biggest problem platform, so just go pick it up, please. Multi-draw, shall I? Okay. The overhead of WebGL draw calls has been a problem report for a long time, and Austin and Kai from the Chrome team did a lot of great work to reduce this overhead by better batching, so they can send down a lot of different draw calls in one shot to the browser instead of iterating in JavaScript. The results from micro-benchmarks are tremendously impressive. You get more than 70x speedups in some cases. So if you're doing a lot of draw calls in your WebGL app, take a look at these extensions. They're still behind a flag, but we're working on getting them turned on in all the browsers. This is amazing. Here's a chart. That's really insane. We're working on improving the batching even further by adding base vertex and base instance variants of these extensions. These are under active development by our colleague Shrek. It's going to percolate to all the browser implementations via the Angle project, and work is ongoing, and you can star this Chromium bug for updates. We are optimizing video to texture uploads. A lot of people doing video conferencing and other kinds of awesome apps using WebGL today, and we're working on reducing or eliminating the texture copies that are associated with that path. Already seeing some great speedups, so you can keep yourself appraised. And finally, we're working on HDR compressed textures and 2-channel compressed textures, and these are just pretty low level, and really Basis Universal is the way to do compressed textures nowadays. And I know that it already supports BC7, and I'm not sure about the other ones, so I didn't want to make claims that aren't true. But these extensions are already community-approved and shipping in some browsers. So basically, this will help you improve your application's visual fidelity. All right, so a lot of stuff going on. Now, we've got a great set of speakers for you today. So I'd like to introduce Yang Gu. Where's Yang? Please come up, and we'll get off the stage. So Yang leads the Intel's Advanced Web Technology Group in Shanghai, China. And so please give him your warmest welcome. Okay, here we go.
Thanks, Ken. Hi, everyone. Good morning. This is Yang Gu from Intel Advanced Web Technology team. Last year, I did an update here, talk about Intel's updates on the web graphics. So here comes some updates for this year. Before diving into the details, let me first introduce my team a bit. We have been focusing on web graphics for about 8 years, and we contribute a lot to the WebGL 2 together with Google. And our current focus is on the Web GPU and WebGL 2 compute. So currently, we are the Intel representatives of the Khronos WebGL working group and W3C Web GPU community group. We have been acting as a quality gatekeeper on Intel platforms on both the conformance side and the performance side. On conformance side, in the last year, we worked very closely with our driver team, that is Windows driver team and Mesa driver team, to integrate WebGL CTS into their continuous integration system. So with this effort, all the changes to Intel's graphics driver that may break the WebGL conformance will be caught timely, even before every check-in. So and we also want to thank great effort, great support from the Google Chrome team for their great test framework on this. And on the performance side, we have been doing the monthly performance test, always against the latest hardware, latest OSs, latest driver, and latest browsers. WebGL 2 Compute is a major contribution from my team. This is basically to bring the OpenGL ES3.1, mostly the compute shader features, to the web. We already have a draft specification published at the Khronos website, and we already have the code available in Chrome on both Windows and Linux backends. And due to the great contributions from the community, we already have very great samples here. For example, we are working on the TensorFlow.js WebGL 2 Compute shader backend. And thanks to the great work by a Russian physicist named Evgeny, he did all the great job to optimize the matrix multiplication based on the WebGL 2 Compute. And we already also have some very great demos related to the compute by the nine-ball syndrome. So as the next step, we will continuously to bring some performance critical features such as subgroup support and the FP system support to this feature. Another issue, another major effort at our side is about the parallel shadow compare. So I get many of you may get stuck for the slow shadow compare. So to answer these questions, our solution is the parallel shadow compare. So with this feature, we remove the shadow compare from the main thread, and at the same time, you can utilize the multiple CPU threads to compare your shadows. We have some performance data here with 2 CPU shaders, 4 CPU shaders, threads, and 8 CPU threads. We can see very obvious performance boost with this feature. Some major WebGL framework like Babylon.js, 3JS already have this integration. Just try it out today. Another good feature at our side is to support zero-copy video uploads into WebGL texture. We already have a draft spec for that, and our first implementations inside Chrome already showed a very obvious speed up on some contents. We will continue to polish this feature. Last but not least, we always have a question, or we always wonder what's the performance diff between the native and the web. What can we do for the web to optimize some general overheads or bring some new features to the web? Our answer to this is a project Aquarium. You may know Aquarium before. This is a de facto WebGL benchmark, but we ported to the native, and we already have a various native backends for it, that is OpenGL, D312, Angle, and Dawn. And we just released the project to the public a week ago. During the implementation, we worked very closely with the Angle team and the Dawn team, and got a very generous support from them. And we also have to find many issues from it and some missing features inside these projects. As the next step, we will continue to port it to various other backends like D3D11, Vulkan, and Matter. So that's it. If you have any questions or suggestions, feel free to talk to me or email me. Thank you.
Thanks, Yang. The collaboration with Intel has just been wonderful. We're very grateful for it. They've devoted a lot of engineering time to the WebGL ecosystem and implementations. So here's Gary from Microsoft, and the Babylon team has also done some awesome work. They've got a great engine. They've got an awesome debugging tool called Spectre.js, and I think we're going to hear all about it.
So a little bit, yeah. Hi, my name is Gary. I work on the Babylon team at Microsoft. Today I'm going to give you a quick update on Babylon.js. If you don't know what Babylon.js is, it's an open source 3D framework on the web written completely in TypeScript. our philosophy is that developers should write the minimum amount of code for every single feature. We strive for very high performance and maintain backwards compatibility. We have a growing community and a lot of apps that are already using Babylon.js. So it's just we released 4.0 earlier a little bit this year. The new inspector makes debugging scenes a lot easier. We have Sheen and clear code support now in our PBR materials. Our package size has been reduced with modules. And we have a new physics integration with Ammo.js. And plenty of optimizations. If you want to find out more, click on the link here. So let's take a look at some new features that we're working on. First up is what we're calling a node material. PBR materials are pretty good, but what about custom materials? We have this thing called shader materials where you have to write custom shaders, but really what we want is a UI-based way of creating shaders. So this feature makes it available for that. I will show a demo of this a little bit later. We're also starting to use the GPU to accelerate 2D controls. First of these controls is what we're calling the timeline control. We're taking the frames from the video frames and embedding it into a canvas control, or a canvas element. And you can see it performs really well. We also started compiling this library called Recast Navigation Library with Nscripten, and we can bring mesh navigation and crowd agents to the web. So you can see those cubes are the crowd, and I'm clicking on the mesh and it's moving around. It's pretty cool. And of course, we're also working on web standards. We're kind of on the bleeding edge for this. We're working with Google on WebGPU, for example, and we can see some great results here. If you want to keep up to date, click on the link here. And also with WebXR, we've been keeping updated as the WebXR spec changes. And of course, GLTF has some new extensions. You've already probably heard this multiple times. With the basis technology via KTX2, we are prototyping these extensions to help define the extensions. And this particular one, if you click on the link, it's a flight helmet that has been reduced from about 50 megs to about 5 megs. And, but just keep in mind that these are preliminary results, and we're still investigating issues. And finally, we've been experimenting with a couple things. This is a marker tracking with what we're calling Babylon AR. It's really easy to use in Babylon. It's just a few lines of code. It's compiled directly from OpenCV using Nscripten without any hand porting. And it's completely open. It's really early. This is just very beginning prototype type of things, and tracking will improve as we fix issues. And finally, we have Babylon Native, which allows developers to build cross-platform native applications with the power of Babylon.js. So you write the rendering code once with JavaScript, and it will work on both the web and native platforms. So, and as promised, I'm going to show a demo. Okay, so here I've set up a very simple scene with a node material, and it's currently it's a very basic node material. You see all that's happening is the color is being outputted. And I'm going to load a pre-existing one that I created earlier. And I'm trying to create a matcap material. So the only thing that's missing here is that I have the normal and the world transform going on. I've remapped it from -1 to 0, 1 as UVs for a texture, and then I'm going to replace the texture with a matcap texture. So just like that, it instantly changes, and you now have a matcap texture over here. So just to prove to you that this is not fake, I'm going to load a different one and add some different features here. Oops, sorry, that's not what I meant to do. So let's start with glass, and I'm going to change the color of this glass by changing a node here. I'm going to add a multiply node. And we're going to add a color node. So it looks the same because it's white, so I'm going to change the color. Let's change some orange. And just like that, I have an orange shader. And I'm going to do one more thing just to make it look more like glass. Just change the alpha value. That's it. There you go. Final step just to prove it out. This is the shader that I generated. Oops. Sorry. I don't know how to use this keyboard, sorry. There you go. All right. If you have any questions, let me know. Follow me on Twitter, ask me questions. Yeah, that's it. Thank you.
Super cool stuff.
Yeah, thanks.
Very nice. Okay. So, next up, I'd like to introduce Ib Green and Tarek Sherif from Uber, and they are doing some awesome visualization, super fast. Whoops, I shouldn't have do that. One sec. Oh, jeez. So Ib and Tarek are working on super fast, super slick visualizations in the browser of large data sets. So please take it away and let's see what you got.
Yes, so this is the third year that we're here talking about our WebGL framework suite. And so we're going to give you some updates on what's been happening. And we've been very busy. And okay, skip that one. So this is the quick overview of the ecosystem. We have, it's grown into quite a comprehensive suite of collaborating frameworks. It's as a visualization team, we serve a large number of applications within Uber, dozens of applications. The only way we can do that in a sane and efficient way is by taking a platform approach and for us making, those platforms open source really has take that to another level. And so that's how we work. All of this is open source, and this is how we build applications inside of Uber. And gradually we've been able to take some of those applications and make them open source. And what we see here is that not only do we have now frameworks like LumaGL or WebGL 2 GPGPU framework and DeckGL or a geospatial big data visualization framework, base map framework and so on, but we now also have frameworks that share data, our internal data for cities and so on, city planners. We have KeplerGL that we talked about last year. But now, this year, we have a couple of additions. We have LoadersGL that we talked about in the GLTF session. We have launched our autonomy platform as open source, and we also have something we call PyDeck we'll talk about. And so this is how we ended the presentation last year. We gave a little bit of a teaser that we were working on, open sourcing our autonomy stack. And I'm delighted to say that February this year, we had all the approvals and we completed the work that we needed. It's a DeckGL-based toolkit that allows you to visualize streams coming directly from the car or the back end of autonomous driving data. And it's a very flexible toolkit, and it's really it comes with an application that you can use, but you can also modify that one or build your own. It has React components that you can compose, you can create your own, and obviously it deals with the 3D world that is generated from the logs. And so this here it's a very comprehensive system. We can only give you a taste. You can see how various channels in the data can be selected, and there's a time slider support and other things. There's also, you can see the live camera feeds being synchronized. A cool thing about this solution is that we are very committed to this. We believe that in collaboration in the autonomous industry would be a huge benefit to everyone, and certainly for Uber. We have made a push to open up our protocol, which we call XVIS. It's an open protocol for autonomous data that we, trying to see if we can move towards a standard. It's very richly featured with the kind of primitives that you would need in this type of visualizations. And if you think about it, then you can say that you can either work on the data source side, where we where we're constantly adding, any kind of de facto or bigger formats. We import the Kitty data sets. We can import ROS bags, autonomy data sets. Obviously, our internal applications generate data here. So we see that growing. and you might be able to get a quick start getting your data into the XVIS protocol. And on the rendering side, we're offering Streetscape GL, which is the DeckGL build thing we just looked at. We're hoping for other renderers. We'd love to see, 3JS, Babylon type renderers being built on top of this protocol. Just to give you another taste, when you work with autonomous data, you tend to work with a lot of coordinate systems. You can certainly work with any coordinate system you want, but these kind of detailed submaps, the continuous coordinate system that's relative to the car and so on, they're all handled natively in this protocol.
All right, so that's the some of the cutting edge stuff that we just released this year, and I'm going to talk a little bit about some of the updates that we've made to some of our more long-standing frameworks. So as a reminder, DeckGL, which you've seen in a few images, is our flagship framework for layering geospatial data on top of base map. So some of the big updates this year, Georgios talked about the GLTF support. We're working on 3D tile support. A lot of pushing stuff to the GPU, like some of the data processing as well. And I'll talk a little bit about that like a new base map support for Google Maps. So this is just a quick demo of, essentially this is trip data around Manhattan, and it's being binned into this screen space grid, and you can see it just every frame, it's updating these 4.5 million points and binning them just at interactive speeds. So a big win for us on that front. So DeckGL, our most mature integration is Mapbox, but we've tried to build it in a way that it's independent of the base map layer that you're using, and we've really opened that up this year with the Google Maps support that I mentioned that was announced at I/O this year. We have a 2D tile layer that lets you import raster tiles from whatever tile service that you want, and then we're also working on integrating the 3D tiles spec, which was talked about a bit in the Loaders GL presentation. So here's just an example of our scatter plot layer, which just lays out points, the geospatial points, and this is being layered over Google Maps. This is showing our tile layer being used to load raster tiles from OpenStreetMaps instead of Mapbox or Google Maps. Sorry about that. Another update is just we're trying to expose Deck just to more environments. So PyDeck is basically Python bindings for DeckGL that allows it to be used in contexts like Jupyter Notebooks. And then the last thing, an announcement that we were really excited about this year. So Kepler GL is our more of a geospatial exploration application that's built on top of Deck. And we contributed, Uber contributed it this year to the Urban Computing Foundation, which is a Linux Foundation initiative for smart cities and that kind of thing. And Kepler GL was contributed to the Urban Computing Foundation this year as their first hosted project. And that's it. Thank you very much.
These are tremendous contributions to the community and to the ecosystem. So Alban, please come up, please come up. Come. Okay, let's see. No, didn't load your presentation yet. Let me do that now. Okay. So let me introduce Alban Denoyel. Sketchfab is now like the #1 site for hosting 3D models, and that's due to incredible perseverance by the entire team. And just awesome work. They've got an awesome renderer, animation support. They ingest everything. They output GLTF too, which is awesome. And it's just been a privilege to see how the company has grown and thrived. So please tell us what's new.
Thanks, Ken. Hi guys, I'm Alban, co-founder and CEO of Sketchfab. Super happy to present our latest update. So yeah, sharing all the major updates from a year ago. So some of you may have seen some of that we presented at GDC in March. For those who are not familiar, Sketchfab is a platform to publish and find 3D models on the internet. Quick numbers, we have more than 3 million 3D models. We almost have 3 million community members. And our biggest recent milestone is that we passed 1 billion 3D model views. So it's probably the largest reach of 3D models on the internet as well. Our biggest update this year is our update to our pipeline to support massive 3D models. Working on web and mobile, supports unlimited polygon size, unlimited texture size. we are building this with WebAssembly, and it's multi-threaded. And so just a quick demo with a few models. And so typically, all those models are between 10 and 40 million polygons. And so this is Norwich Castle. And so we tile every model into 16K texture resolution, and then we stream the content with level of detail for both the geometry and the textures. And so yeah, it's going to be a great fit. So it's mostly focused on 3D capture data, and typically great for things like cultural heritage, aerial 3D mapping, drone 3D capture, and so on. And so this is provided by Reality Capture, offering a great photogrammetry solution. And it's loading again. Sorry. And so you should be able to almost read the license plates on the cars now, whereas last year we just had vertex color, essentially. Another big update is around our Viewer API. Now we ship updates to the Viewer API every quarter. And so this is all the things you can do on top of the Viewer to customize the look and feel of both the Viewer and what's happening inside the Viewer. We've added a lot of things around annotations. You can create and delete annotations on the fly with the API. And then we've exposed lighting for the API. And so it lets you build much more interesting and powerful things on top of Sketchfab. And so here is a quick demo we worked on with Audi. So we're shipping more and more 3D product configurators. And so it lets you very easily deploy an interface to tweak, like go inside and outside, so change camera views, and then tweak colors, materials, hide and show objects, trigger animation. So here, opening and closing doors, and then very easily changing colors. We've added Magic Clip support for both upload and viewing, which is pretty cool. So on the upload side, we worked with Spatiate, which is a creation app for Magic Clip, and they've added a native export to Sketchfab, so you can create in AR and then publish to Sketchfab. And then we've worked with Magic Clip to support the entire library through WebVR, WebXR, which is pretty cool as well. And then we've expanded our model inspector with bone support. And so for any animated model on Sketchfab, you can inspect the bones and the bone influence. And so typically, if you want to buy a model on our store, you can really see what you're buying and how the model is built, which is a big change for the store. We've added automated ground shadows, so either real-time if the model is animated or through baked ambient occlusion. It's really great for product display. So on the left, without, you really have an object that is floating in the air. And then with just a very simple light ground shadow, it becomes grounded on the floor, which is nice. And then we've added, I'm going to not pronounce this well, anisotropy support, which is just this fine little effect you can see on the right, which is great for balls for Christmas or nubs, things like that. And that's it for me. Thank you.
Again, it's just been amazing to see how Sketchfab has grown. May I introduce David Koerner from ESRI. ESRI does amazing geospatial products, creates amazing geospatial products. Is yours already? Yeah. Okay.
Yes. Hello, everybody. My name is David. I work at ESRI, and there I'm working on in the JS API team. So for those of you who don't know, ESRI is most known for its ArcGIS Pro software, which is software for authoring and analyzing and publishing geospatial data, and also doing geospatial data analysis. And it's been a long time since then, and since then ESRI has grown and now has a vast ecosystem of products around GIS, and we have like cloud platform and everything. And the JS API is kind of the API which allows to bring in the data, visualize it, and analyze it in the browser. And WebGL is a key component of that, obviously. So this is just the JS API. So we are we're doing realistic rendering of cities up to really abstract data visualization and everything which is related to spatial things. So that's kind of a summary of the API. And we have two main thrusts which we are working on, where we basically work with WebGL. And the main important thing is visual quality. So we always try to improve the visual quality and make rendering more realistic. So now we also are moving towards physical-based rendering. So we are joining the party fashionably late, but we are getting there. So we basically walk down the well-beaten path, which has been done before. And that's basically what we do here. And also we now support GLTF, and this is a key part because it has this physically based rendering standardization basically, so we are able to leverage this, and we are basically now rolling this out through all our platforms, and we are planning to really increase the visual quality of our cities and GIS visualizations. And then we introduced within the latest release a couple of weeks ago, we introduced realistic water rendering, or we try to make it look more real or better. So we basically here use WebGL to basically have a procedural texture distortion which is animated. And this will be used to visualize water bodies across the industry which use the GIS data. And the other second main thrust which we are working on is to allow stronger interactive experiences for authoring and data exploration. And here Ken mentioned the BIM model in the beginning of the session, and then we have recently moved towards BIM. We have a collaboration with Autodesk where we directly read their Revit data, which is the BIM data, and we use WebGL to really allow to explore these data sets. So here we use the discard functionality in the shader to be able to slice through the BIM model and visualize, basically allow visualization or to explore the data set, which is very complex. So that's one of my favorite features, actually. I really love this. So, and moving forward, as I said, interactive authoring is also a big part of this. So we recently introduced sketching and drawing. So you basically can create data sets like this. You can draw geometry and manipulate it, move things around, and then you can also place things. Yeah. Use manipulation, and then we have manipulators for moving the data around, and this is all part of our API, and so that's really cool for us to allow people to go in and manipulate and edit the data, not only look at it in the browser. And so we use this also for interactive data exploration. So we have this point here, and then we can set the distance, and we can basically draw interactive masks for our data and move the masks around to basically analyze the data like this. And also we use WebGL shaders. We move a lot of more and more things to WebGL shaders. So here the geometry generation. So this is the trajectory of the hurricane, and we have these line segments. And now we basically evaluate the geometry positions in the shader to be able to allow fast updates of the data set and be able to explore the pressure in this case of the data set. And that concludes my talk. Thank you very much.
That's really cool to see how you can not just browse the world, but also create new worlds. Okay, so may I please introduce Will Eastcott from PlayCanvas. Will's been building AAA games for a long time, a lot of great experience, and created the company PlayCanvas to bring authoring and collaborative experiences better to the web. And it's been just a privilege to work with you, and excited to see what's new in PlayCanvas.
Thank you, Ken. Well, hello everybody. My name's Will Eastcott. It's a pleasure to be back here at SIGGRAPH to give you some updates on PlayCanvas news. Let's go full screen. There we go. Okay, so just in case you're new to the WebGL community, just to give you an overview of what PlayCanvas is, it's really a game engine for the Google Docs generation. It's online, it's real-time collaborative, and it's all built on an open source, super lightweight, very optimized WebGL runtime. Now, last year, I showed off some pretty big projects that the team was working on. For example, our GLTF 2.0 compliant loader, and also our integrated version control system. So now in PlayCanvas, you can create checkpoints, create branches, you can do diffs between checkpoints. So everything you'd want from a version control system is now built right into the editor. But what I really wanted to do was show you some real-world applications of some of these big projects that we've now completed. And back in April 4th this year, we were proud to launch Snap Games. And Snap Games is a new way to play video games with your best friends in Snapchat. And PlayCanvas is the required game engine if you're going to be building games for this platform. Let's check it out. Okay, so I can't go through everything that we built to prepare for the launch of Snap Games, but one thing that's really close to my heart are the user interface creation tools that we built. So let's look at the content, or some of the content that's been built with these new tools. So starting out with Bitmoji Party, you can see the player drop into the shop, and here they're browsing all of the different things that you can purchase. There's SDF fonts, and there's buttons and images and scroll views, everything that you'd expect in a complex user interface. But the cool thing is that this UI was built by just a designer with practically no coding required. Another interesting app was Bitmoji Tennis. And here we used a technique of dynamically rendering 3D Bitmoji into textures and then using those as image elements in the game's UI. I think the important thing to note here is that WebGL tooling is really, really advancing to the point where HTML5 WebGL games are starting to look like native games. That gap is really starting to close. So what else do I have to show you today? Well, I also wanted to just quickly run this demo, which may be familiar to you, except it has, whoa, lovely. I'm just going to reload that page. Okay, let's do that again. I probably won't go full screen this time, just in case it screws it up. Anyway, but this is an application that was built in collaboration with ARM. It's it's an advanced technical demo showing some pretty up-to-date rendering techniques in WebGL. Now, this is something that was released in 2016, but unfortunately, this was built on a forked version of PlayCanvas, so we were never able to update this application. So what we've done is we've completely rebuilt it from scratch, using the absolute latest techniques and features in the engine. And I want to show you what 3 years of PlayCanvas improvements can do. So the second version of the demo is built on WebGL 2 instead of WebGL 1. The load time is reduced by a factor of 5, the download size by a factor of 6. It uses a host of new hardware texture compression formats. The number of lines of code required has halved. And we're also using a few optimizations in the PlayCanvas engine, like draw call batching and shader precompilation. But I think the coolest thing I'd like to announce today is that we are, in collaboration with ARM, open sourcing this demo to give back to the developer community so you can see exactly how we built it. Thank you. So the last thing I just want to mention is that I am hiring. So if you're looking to join a company making a cool WebGL engine, please come and talk to me about that. That's all I got. Thank you very much.
That's awesome stuff, Will. Everybody should go try PlayCanvas and build something cool. Now, how do we get out of here? Okay, so you're cell, yeah. Right, it's here. It's the one underscore working. We promise not to crash PowerPoint with this presentation. All right, so let me please introduce Stein. So Fraunhofer makes a lot of products, but among them is Instant 3D Hub, which is a CAD/CAM tool for massive models, and they do incredible data streaming down to the client. We collaborated with them on the WebGL multi-draw extensions to prove them out in a real-world app, and we're going to hear that and a bunch of other updates, so please.
Yeah, hi everyone, thanks for the introduction. I'm going to jump through a number of topics, so I'm going to quickly state the difference here. So XFreedom is our declarative solution for 3D rendering directly in the canvas by embedding the X3D SIGGRAPH into the DOM. And in contrast, Instant 3D Hub is our scalable 3D service solution for visual computing tasks in industrial use cases. We're like in a celebration mode, so XFreedom has its 10 years anniversary, and I want to give a special thanks to our developers Timo and Andreas for providing all these new features like WebGL 2, GLTIF2 support, physical-based rendering, and the WebVR integration, and many more. Our industrial customers are usually providing their data as a graph of linked resources, and we think that this is a key concept for the distributed web of 3D data. So based on this RFC 2077, which defines the model domain with 3D object as payloads and links inside the model domain, we want to propose the extension of the GLTF asset with a models array, which can contain either URIs to external files, to embedded base 64 encoded data, or references to the buffer views with a MIME type. And we have already implemented the extension inside XFreedom. And this example shows you how with a small node structure you can easily instantiate a local mesh, a linked GLTF, or even a linked model in a different data format, in this case an X3D. We want to thank the Chrome team for adding the multi-draw extension, and I want to give some details about why this is really beneficial for us. So what we are doing is that during our internal transcoding to our caching format as a pre-step for the visualization, we are breaking down the SIGGRAPH structure for spatial optimizations like better visibility computation and batch rendering. And while this is nice, as long as you're rendering the full model, during interaction, users will change the fragmentation state of the submeshes, and this can result in a huge number of draw calls like in this color coding here on the right. And the extension from Google helps us to retain high frame rates even on low-performing devices. Another topic we are working on is that more and more customers are now trying to not only have the engineering colors as rendering, but also link their CAD parts directly to some external high-quality material data. And for that, we are working on an automatic material library and cache generation, which should allow us to easily address materials like in this URN, but also allow dynamic reassignment at runtime. And this here shows a visual comparison of the same input data visualized with a ray tracer and an Instance 3D Hub based on GLTF PVR. Finally, I want to give you some more details about current feature set of Instance 3D Hub. So what we're seeing here is how a shared session service can be used to synchronize states over numbers of different devices or multiple users. And last year, we've already shown you server-side model tracking using the VisionLib, which is also from a spin-off of Fraunhofer IGD. And what we can do now, and what you'll see in a second here, is that we can do a client-side fusion of the local SLAM with a server-side model tracking, which then results in a really high-quality experience of the tracking. And using the generic data streams API that we provide with a shared session, the remote client can now directly subscribe to the view matrix stream or the camera background. And with this, you can do things like remote assistant scenarios, with the difference that the actual augmentation rendering still happens on the clients, and anyone can interact directly with the full data set. And the technology you're seeing here is used by Siemens to build their maintenance and service guides for these electronic engines. And if you want to see this for yourself, have a demo or play around with it yourself, please visit us at our booth. Thanks.
That is awesome stuff. Thank you, Christian, for sharing this. Okay, so last but certainly not least, I would like to introduce the man who hopefully needs no introduction, Ricardo Cabello. If you, well, okay, hang on a sec, let's. No attention to all the swap computers. You may have noticed that we got it down to one machine swap this time. So if you're using WebGL, you're probably using 3JS. 3JS is the way that most websites get access to WebGL. And it's a well-designed, thoughtful API that's got a ton of features and a huge community around it. And Ricardo leads that effort in that community. So please share with us what's new in 2019 in 3.
All right. Hello, everyone. Last year, the update ended up being, I ended up doing a presentation of 60 slides, and it was too much for 5 minutes, so we'll see how this year is. So, all right, so I'm Ricardo. I run the 3JS project. I'm going to start quickly by showing like a recent realization, and is that even if nowadays we have smartphones, there's still people that find smartphones intimidating. So instead, they buy like non-smartphones or dumb phones, however you want to call them. Not only for the price, but just because they're intimidated. They're scared of like use touch screen. So I actually like got one of these ones. It's something like $50, something like that, $60. And the first thing that I usually do is like, and I also heard like it runs a WebGL. So this is a demo I did in 2013. I did it on a Chromebook, so at the time, like 2013, where the Chromebook that was kind of limited, to me it says like a good example, like, all right, whenever I have a new phone to device, or like a new device to try, I just try this demo. So I was actually surprised that, even if like you still had to use, those controllers at the bottom to select things and to go to the browser and like to type, all those like we're used to with like tapping 3 times the key for letters and stuff. We actually have a, let's see. Oh. It's not super smooth, but it actually runs. And And this is more like a, like thanks to like all the WebGL people, the WebGL community, making sure that this is working. Like it's like to me, it's impressive that you do something like in 2013 and you still try it in any new device and it still works like at the time. It's a good testament for WebGL itself. So thanks WebGL people. All right, so I'm going to show quickly some of the projects that nowadays people are doing with on the web. A little bit more like advanced maybe. So this is some interesting things that people are starting to really combine, like HTML, or like doing websites, traditional websites as we know as scrolling, but like putting like WebGL elements on them. So like this is a website for Doc Studio, and yeah, it just has like a really nice model on it. But like I really like the fact that sometimes the text goes behind the model. But yeah, this is actually HTML. Yeah, they do a good job of combining all these things. Another example, the Web for Lucian. This is an agency like in UK that they're pretty good at like doing very advanced 3D graphics for websites. So it's the same thing, like this is all real time, and especially if you go to the About section. Kind of redefining a little bit what we expect as websites to be. And one last one, like this one, something that also some other agencies are trying to do, where they don't try to have too much 3D on the website, but they just want to like utilize WebGL on top of it. So what they're trying to do is to have like a JavaScript that is parsing the DOM and converting that DOM into WebGL elements, and then they're applying a shader on top of it, so they can do this kind of effects that you couldn't do. You basically cannot do with CSS. All right, so going back to the library a little bit, I think it was early last year that we adopted monthly release cycles. So, and I tried to make it like on the middle of the month, but eventually like ended up being like the last Wednesday of every month, which happens to be today. So today's been a long day. So managed to like release a new version, like the R107. There's not a lot of new features into it. Like we're trying to have like stencil into the materials, basically cleaning up some of the examples. But every version, every release is more like cleaning up the API and making sure that everything's nice. So yeah, so this is 9th year. And this year we really focused on developer experience itself, like really making it much easy, like trying to see where people are having issues with, and like try to see how we can help the WebGL community or the HTML community really. So starting with thanks to you and Chen, with the website redesign. So this is kind of the website where everyone goes to like get information, so try to make it much nicer. Same with like documentation, which is probably the most visited page on the website itself. Like making it much easier to read, like also like on mobile devices. And also make it, the Chinese community has also done the translation for the documentation themselves. Which is also surprising, which is interesting because the Chinese community actually, or the Chinese are, there is more people from China these days than from US on the website. So I think it was a couple of weeks ago that China managed to like get more interest on the library than not US, which is also surprising. Also, we have, Jordan Santel has been working on developer tools. Try to show it. So it's the developer tools that you can install for Chrome and Firefox. So whenever you go to any example, like now you can see the SIGGRAPH of that example, or you can like hide. Like this is very early days, but you can, in this case, you can pretty much only like hide elements and like inspect materials, and like, but the idea will be to, yeah, like one of the problems that we saw is that people, whenever start like programming something, usually they get a black screen. It tends to be because the camera is inside the object, or the object is behind the camera. So we're trying to like, yeah, try to make it more like help a little bit on that. Like maybe at some point have like a orthographic view of the scene, so that people can have like a better visualization of what it is that they are programming. And also like we're trying to make it as a part of the developer tools, which is, we believe is like kind of like the webby way of doing it. Also, we've been we converted like all the source code we already had on ES modules, but we converted all the examples and all the additional controls and like loaders all to ES modules. So now this is how you used to develop before, like importing 3JS and importing all the objects, like all the loaders, but it was all basically adding everything to global scope. But like now you can just have like a new GSM folder where you have all those modules, like all the same files, but you have it as modules. And this allows to, anyone that want to like start extending the library is much easier than not to have to like include like the old way. But what is important is that we keep both ways. So for people that are used to still developing the previous way, they can still do it that way. That has allowed to something like a React Tree Fiber, which basically is a library that sits on top of 3 or uses 3, but it basically is a React abstraction on top of 3. So you're more used to like develop in React. Now you can use that approach. Like I personally don't know how to do React, so I don't understand this very well, but it works, and it allows you to create this kind of the same kind of effects, but basically is a more visual way of developing. Well, maybe that one is not going to load. Also TypeScript. Everyone is always suggesting to convert the library to TypeScript, but it will be also like you will be leaving behind a lot of developers. So eventually we opted by adding definitions, like descriptions to every file. So now in the source code you have a DTS file that whenever you're developing on TypeScript, it's going to give you all the types for all the functions. And we keep that like up to date every release. And lastly, like there is people that are not interested in even like typing JavaScript or typing TypeScript. So for those people, the team at Google, we've been working on a web component that allows them to basically, with JavaScript, you just include a file, and now on your website you can create a model viewer tag, which allows you to display GLTF models. And maybe this, let's see. Yeah, so basically like you will be like do a normal like HTML website, and here this will be like a model viewer tag that it acts like a normal image or like a normal video, but it's how you used to develop with HTML. And lastly, this week somehow seemed logical to create at some point like a Twitter account for 3JS. So follow it if you're interested in 3JS updates. You don't have to follow me anymore. And what was interesting about this was like seeing like Babylon.js also saying hi back, library to library. And that should be all.
So we're way over time. I apologize for keeping you from lunch, but thank you all for coming. The presenters are going to be around, and so please come and ask us questions. Sorry we didn't leave time for Q&A once again, Mark. I apologize. I hope you leave as inspired as I am to see all this cool stuff and go out there and make awesome stuff on the web. So thank you for coming. And please come to the Khronos reception 5:30. You may have heard there's free food and free drink, so why not?